Hi everyone, and welcome back to the Chapter 15 video lectures. In this video, I want to talk about how crime scene investigators collect firearms evidence, and then also discuss the comparison process for firearm evidence. So how do we collect firearms at a crime scene? First, we must prepare the firearm for transport. Investigators should record the serial number of the firearm, and they should unload all ammunition and magazines from the weapon. On a revolver, it's important to identify the original chamber position of the bullet, so investigators will mark the chamber that currently aligned with the barrel. After those steps have been completed, you're ready to package the firearm. It's important that the firearm is not jostled or damaged by other hard objects, so you should make sure to package all components of the firearm separately. You should also secure the firearm into the container so that it does not jostle during transport. This photograph shows an unloaded firearm that's attached to the bottom of the box with zip ties. This weapon is prepared for safe transport, as the zip ties will stop it from bouncing around in the package and damaging either the weapon or trace evidence on the firearm itself during transport. A few cautions when packaging evidence. First, never package a loaded firearm. This can result in an accidental firing during transport, which can endanger the forensic technicians and other law enforcement officers. The second caution attempts to reduce the amount of latent print destruction on the firearm. When packaging a firearm, it is best practice to handle the firearm using only surfaces that are not conducive to fingerprints. Oftentimes, the grip of the weapon is textured, so it can be handled without concern about the loss of latent prints. Smooth areas, like the trigger and the barrel, are prime surfaces for latent fingerprints, so reducing the amount of handling can reduce the potential for evidence loss. And finally, unlike what you see on TV, never insert anything into the barrel of the gun. I have no idea why this became a common visual, but a lot of times investigators on television will insert a pencil or another object into the barrel of the gun to pick it up. Protection of the barrel is of prime importance in ballistic analysis, so you must preserve that evidence as best as possible. So how do you collect ammunition from a crime scene? Just like the weapons themselves, it's important to protect the ammunition during transport. Make sure that all ammunition is packaged separately so that the bullets will not hit and scratch one another. Some departments may require you to mark the bullets recovered from a crime scene, but otherwise it's recommended to avoid marking the bullet in any way. Fired bullets may be recovered from surfaces like walls, furniture, etc. It's important to try to avoid scratching or otherwise damaging the side of the bullet when removing it. Although it varies, some agencies prefer crime scene investigators to actually avoid removing the bullets directly and to take a full piece of the surface back to the laboratory. This means that if you find a bullet in drywall, your agency may require you to cut out a small square of drywall and bring that back to the laboratory. At the lab, analysts can use more caution to recover the bullet from the surface and hopefully preserve the evidence on the side. The process of conducting a ballistic analysis typically involves a comparison microscope. This special microscope allows analysts to overlap two microscopic images to find pattern similarities between both samples. Of course, in order to use a comparison microscope, the forensic analyst must first have two separate samples. In this case, analysts will use a known sample, meaning one that came from a known source, and an unknown sample, or a sample from the crime scene or the victim that does not have a known source. Before actually putting the samples into the microscope, analysts will use the class characteristics of the firearm or the firearms to compare against the unknown samples that are collected at the crime scene. Investigators use bullet traps, like this water trap depicted here in the photograph, to test firearms. The water slows the bullet down without actually damaging the sides, something that would be very difficult if the test fire was conducted into an actual target or an actual surface. Once you've collected the fired bullets, you can compare the knowns and the unknowns visually. When examining cartridge casings, investigators can compare the marks made by the firing pin and the ejector. The photograph on this slide shows a comparison of two firing pin impressions. Now, based on this impression, what type of fire do you think this cartridge casing was? If you said center fire, you're correct. The indentation in the middle is from the firing pin, which is hitting the cartridge to ignite the primer. Some firing pins create square or oval shape impressions, and that can also be used as a class characteristic for comparison. On fired bullets, investigators compare the markings along the side of the bullet, called striations. Striations are formed in part by the manufacturing process, specifically the machinery that's used to create the lands and grooves inside the barrel. The most common rifling method involves a scraping of some form, and that leads to an individualizable marking that can be compared. The photograph here shows the striation marks inside a land impression on a known and an unknown bullet through the lens of a comparison microscope. Like fingerprints, firearm comparisons have changed with technology. The Bureau of Alcohol, Tobacco, Firearms, and Explosives, or the ATF, manages a database called the Integrated Ballistic Identification System. IBIS is designed to help forensic analysts store, search, and compare fired bullets and cartridge casings with other agencies across the United States. Also, like fingerprints, the system is used to help analysts find possible sources by producing a short list of similar samples, but the final comparison is always done by a forensic analyst. There's a huge caution with ballistic evidence. Barrel markings are not permanent. The striations within a weapon barrel can be affected naturally by multiple firings, by dust or rust inside the barrel. Striations can also be affected if an object is inserted into the barrel of the weapon, something that is usually done on purpose to destroy the ballistic evidence. If the striations are substantially changed, it may not be possible to match a bullet to the proper firearm. At the best, a forensic analyst may only be able to state that the weapon cannot be excluded as the origin of the bullet recovered. All right, well, that concludes the second video lecture for Chapter 15. Join me in the final video lecture as we discuss tool mark evidence.